On to the exercises. Number 1, find the maximum number of a 16-bit integer using arithmetic operations. We're going to actually raise it to the 15th because we have to consider negatives in that direction in the same amount. So if we do this, we say int 16, it's going to be one less than that because of the 0. All right. Number 2, construct a series that has the nullable integer data type. Make sure it has a mix of integers and missing values. Okay, I can do that. So series, say negative 100, 500 pd.na. We will make this d type capital I int, say 16, since it can cover these. All right, number 3, take a look at the series below. Changes data type such that it uses the least amount of memory and preserves the numbers as they are. So let's change this as type. So if we say, so this is 1,000 and 60,000. So if we use an int 64, that will work, obviously. If we use an int 32, that will work. Can we use an int 16? Okay, no, that doesn't work. But can we use an unsigned int? Okay, so we can do that. So that is the least number. If you go, you can use int 32, but that uses 32 bits, and we're trying to find the least amount of memory that preserves the numbers. All right, number 4, find the precision of a 32-bit float and then create a NumPy array with values that have decimals past that precision. So if I do finfo float 32, the precision is 6. And so if we create a NumPy array, so I didn't talk about this in the videos, but it's basically the same way that you do with a series. So just have a list over here. And then I will say d type equals float 32 like this. So we can see here that looks like it preserves everything. Well, it doesn't actually quite get the last one. If we add more decimals, we should see that it does not. Let me just make these into decimals so it's easier to see. All right, so it has, okay, so 5.234, then another 234. Actually does keep that, but then it just cuts them off over here. Let's just make sure, let's get the very first one. Yeah, so it doesn't have enough precision to hold all of the decimal places like that. So that's what we're doing. We're just putting more decimals than it can hold. So more than 6 digits of precision. Number 5, create a series of numbers that have decimal places. Use the as type method to convert it to an integer and then back to a float. Are the decimals from the original series preserved? Okay, so we have a series with decimals, so just say 4.87, 3.94. Let's call this S. Let's convert it to an integer, say a 64-bit int, and then we can chain another as type. If we convert it back to a float, will we get back our original decimal places? Well, no. It doesn't remember those decimal places. Number 6, create a NumPy array with 8-bit unsigned integers. Use negative numbers in the construction along with numbers greater than 255. Does the output make sense? Can we do this, number 1? So say negative 50, 100, 300. We're going to create d type equals unsigned int 8 like this. Does this even work? Okay, so it actually does work. It wraps around. So the lowest number is 0 for an unsigned int. So this is 50 more than that. So so this goes around the other way. So it starts at 256 and it goes down 50 to 206. So that makes sense. 100 stays the same. 300 wraps around. It's 256. It's 44 more than 256. So that makes sense. Number 7, create a NumPy array that has the values 50 and 100, but do so without actually using those two values or any operations that create the value. So what I want you to do here is, let's use this same idea as above here. So I can just copy and paste this maybe. and I want to see 100. So I need to go, so if I put in 356, that's 100 more. I guess 306 would be 50 more. So that's how you could do it without actually writing the numbers 50 and 100. Number 8, create a NumPy array that contains 2 integers and the NumPy nan missing value. Assign it to a variable and output it to the screen. What data type is it? Okay, so we have np.array has 2 integers, so let's say 5 and 10, and the NumPy missing value. Assign it to a variable. Okay. S. Should call it A for array. Okay, and then what is its data type? Okay, it is a float 64. All right. Construct a series from the array. Create an exercise 8. What data type is it? So I just put this in. It's also a float 64. Construct a new series with the same array, forcing it to be a nullable integer. Okay. This is the second part of the question. So we say D type equals capital I int 64. So that does work. Construct a series of 32-bit nullable integers using the data type object itself and not the string. Okay, so pd.series, we'll just, again, it doesn't matter, pd.na, and the D type will be this. This is what I want, the nullable. We can do an unsigned nullable integer to make it more interesting because we don't have any negative numbers. So that will work like that. So that's what I wanted you to do, use this without using the string. All right, so that does it for the exercises.